Welcome back, everybody. The next speaker is just us with the director at Let's Encrypt. If you don't know Let's Encrypt, I wonder what you're doing in this meetup. So Let's Encrypt started back in 2015, and when I got my invite to be part of their private beta, I literally danced of happiness. So Let's Encrypt really made something in my life. I really love these people, and I'm so glad to have them here with us today. Hello, Josh.
Hi, thanks for having me. Can you hear me all right?
We can hear you all right. So
Great. Well,
you are
it's
probably
nice to
the
be
reason
here.
for my X509 addiction. How do you feel about that?
Well, first off, I apologize. Um, but it's great to be here. You built some really great stuff with Certmanager. You know, it's one thing to operate a CA, but we need software out there to make it really easy for people to fit into their software stacks and just make certificate management as transparent as possible. It seems like you're doing a great job. So thank you.
Thank you. So this is a Q&A session. Josh, do you want to first give like a short introduction to the people? What is Let's Encrypt, how it started, what are you up to? And then people, if you have questions, you can put it in the YouTube chat, which is on that side, no, that side of the screen. So post it there, I will be taking questions there and we'll be asking them to Josh.
Thank you. So as Marcia said, Let's Encrypt is a certificate authority. We're a nonprofit certificate authority, so we do not charge for our services, and we try to make them as easy to use as possible. And the reason we do all of this is that we want to secure the web. So we want to get the web to 100% HTTPS. And when I was at my last job, I spent a lot of time trying to think about how to encrypt the entire web. And when I talked to people about why their websites weren't encrypted, one of the most common answers I got was getting certificates and managing them is too difficult. They either cost too much money or it's just too much of a pain to go through the process to get them. So we thought that one of the best things that we could do to try to encrypt the entire web is make a new certificate authority that removes all those barriers. No charging money, make it as easy to use as possible, an API that can be accessed through software that just handles everything for you. And in an ideal world, you don't even really need to know about Let's Encrypt. You don't need to know that you have certificates. In an ideal world, the software just gets all this stuff for you and manages it. So we want to be as transparent as possible in your work every day so that it is just a no-brainer for you to turn on HTTPS for everything that you do. So we started in 2015. We started issuing certificates in 2015. Now we're serving more than 225 million websites. We're doing that with issuing a little under 2 million certificates per day. And yeah, our goal is to get to 100% encrypted web and stay there. So what else can I tell you?
That sounds awesome. I already have a nice question in the chat. So currently Let's Encrypt issues certificates that are valid for 3 months. And people apparently find Certmanager so easy to use, they wonder why 3 months and not 1 week, because the automation works so well.
That's a great question. So when we started, most certificates were a year or more, and we wanted to move that down for security reasons. So for people who don't know, when revocation doesn't work very well when you have a problem with your certificate, or more specifically, when you accidentally expose your public key or your private key and have some sort of security incident. You're supposed to revoke your certificate, but that doesn't actually work that well. It might not be effective for everybody who's visiting your site. The only thing that really ends the life of a certificate is its expiration date. So instead of relying on revocation to remove a certificate from the ecosystem, we just want to have short certificate lifetimes so that they expire rather than be revoked. So this is a great question of why isn't it even less? So at the time when we did 90 days, that seemed like pretty short compared to what people were used to. And we kind of got a lot of flack for it because I think people weren't used to the idea that if things are automated, then it really doesn't matter what the lifetime is. But now I think people are more used to that and starting to ask this question of why not shorter. There are a few different answers to that. One answer is that it's a bunch of work. So for us, having one certificate lifetime, and we know that all certificate lifetimes are like that, is sort of a nice assumption to be able to make. And if we want to add another certificate lifetime, we have to do some work on our end. That's not the end of the world. We're already starting to plan out that work. The next question is, how low can we go? There starts to become some limits at the lower end of this. So you run up against certain regulatory requirements, things related to OCSP responses. I don't know how low we're ultimately going to go. I would hope that we will start issuing certificates that are valid for between 7 and 10 days within the next year or two, but it is hard to say. I hope that's helpful.
One follow-up question. Will you be able to make it configurable for users if they still want 90 days or if they want 7 days? Is there an option to let users ask for specific validity?
We haven't made any final decisions about this, but what I think is going to happen is you're not going to be able to choose any lifetime you want. We'll offer a certain number of choices, so you'll be able to choose something like 90 days, 30 days, or 7 days. I don't know that those are the exact choices you'll be offered, but I don't think it will be entirely user configurable where you can pick anything. We'll probably offer 2 or 3 choices.
Sounds good. If you have any more questions, please drop them in the chat. I had 3 ones which I received before today. So, Certmanager caused you some trouble, I think, a year ago, more than a year ago. I remember myself getting an email to replace my Certmanager. It was 3.8, I think. Do you know more about what happened there?
Yeah, so for a while, unfortunately, we have this list of clients that send us too much traffic. And for a while, Certmanager was occupying most of the top 25 clients doing that. And I think there are a few different bugs involved, and I'm not really prepared to say what each one of those bugs were, but I can say that there were a couple different categories of bugs contributing to the problem. One was that Certmanager wasn't storing enough state locally. So it wouldn't keep track of its interaction with Let's Encrypt. It would just go back to Let's Encrypt every single time it wanted to know something. So for example, if there was a failure, instead of keeping track of its own failures or triggering some kind of error that might help you figure out what's wrong, it would just keep asking Let's Encrypt over and over and over again for cert under failure conditions. And so anytime something was broken with a Certmanager install, you might just get it repeatedly asking us for certs again and again and again. So that was part of the problem. Then I think, yeah, I think pretty much everything falls under that category. It just was not keeping track of local state and was constantly checking with Let's Encrypt for things that it should have already known about, if that makes sense. But in more recent versions of Certmanager, that is not a problem. Every once in a while something pops up, but I think we're not seeing major issues there anymore. I guess one thing I can add is that there's sort of this idea in Kubernetes, in the Kubernetes ecosystem in general, that you don't want to store state. But when you don't store the state of things on your side, you can end up sending a lot of traffic to external services because you're essentially treating them as the place where you store state. Does that make sense?
That sounds good. So in the intro talk I mentioned Let's Encrypt's changing root CAs. Can you tell us more about the changes that are happening there on September 29th?
Sure. We've got a few different changes that are happening with our roots of trust. So I'm just going to start from the beginning here. When we started Let's Encrypt, we made our own root. It's called ISRG root X1. But nobody trusted that root, so it didn't make sense, it wasn't helpful for us. So we got a cross signature from an organization called IdenTrust. So since the beginning, we've been entrusted via IdenTrust. So your browser doesn't really trust, well, your browser probably does trust Let's Encrypt now, but in the beginning, your browser didn't really trust Let's Encrypt. It trusted us because we were cross-signed by IdenTrust, and your browser did trust IdenTrust. But now the Let's Encrypt root X1 has been propagated widely enough, and your browser probably does trust it. So we don't really need the IdenTrust cross-sign anymore. So next year, that's going to go away sometime in September, I believe. So by September of next year, everybody is going to need to be chaining directly to the ISRG root and not the IdenTrust root. This is good for us in that we do not have the added complexity of a cross-signature from another organization. So for us, that puts more administrative burden on us. It makes the chain of trust more complicated. So that's going to go away, and that's good. Part of the thing that is tricky, though, is that the IdenTrust root is more widely trusted than our root. Our root is pretty widely trusted, but when it comes to things like especially really old versions of Android, there's still a bunch of, very old versions of Android that are out there in the world that don't trust the Let's Encrypt root directly. So that's the thing that we are most concerned about, but I think for most people that's not going to be a huge issue, but we are paying close attention to it. So that's what's happening with transitioning away from a cross-sign and into using our own root X1 directly. The other thing that's happening is that root X1 is an RSA root, so it uses RSA cryptography. Last week, actually, we generated a new root called root X2, and that's an ECDSA root. And we generated some new intermediate certificates for ECDSA as well. And the advantage here is that ECDSA is computationally more efficient, so it's a little bit faster when it comes to computation, but also the size of the certificates are smaller. So if you're using ECDSA, you're going to have a little bit faster experience computationally, but you're also going to be sending less data over the network in a handshake because the certificates are smaller. And in the end, you're getting roughly the same or better level of security. So we're pretty excited about being able to offer that. And even though our root X2 is a new root, and again, not widely trusted directly, it has been cross-signed by our first root, root X1. So you should be able to use it relatively soon for anything that you could use root X1 for. And those are the big changes. So that's a big deal for us to have generated the new ECDSA roots, because the key ceremonies that go involved in generating these things are very complicated and tedious to make sure that we get every little detail right and we do it all very securely. So we did that last week. It went really well, and pretty excited about that.
Congratulations on the new root. I got a follow-up question from the chat, which is why not ED and then the number 255119, which is a nice name to pronounce.
So I am not an expert on this issue. I can tell you why I think we did not choose that algorithm. I believe the reason we didn't choose that algorithm has to do with compatibility with browsers and clients and other devices. So when we're choosing what cryptography to use for our root and intermediate certificates, first of all, we have to pick things that work with our hardware at Let's Encrypt. So private keys and all these things are generated on what's called HSMs, or hardware security modules. They're basically just special computers that protect private keys. So we need those devices to support whatever we're going to use. And then we need to be confident that browsers and all the other kinds of clients out there have broad enough support for whatever we pick. And I believe the reason that we didn't ultimately pick, I think it's 25519, is that compatibility is not where we would like it to be. Again, I am not an engineer at Let's Encrypt, so I might not be 100% on with that answer, but I'm pretty sure that's the right answer.
If there is a Let's Encrypt engineer in the chat, please shout now. So I have a next question. Let me try to ask them in order here. So do you see yourself replacing enterprise certificate authorities in the future?
And that's certainly not our goal. We offer a pretty specific service. We offer DV certificates, 90 days, automated. Everybody gets the same thing. There are a lot of things that other certificate authorities offer that we don't. And I think those things that they offer are very valuable to different organizations. So I think we're going to work hand in hand to encrypt the entire web. I don't think it makes any sense for Let's Encrypt to be the only CA. Like I said, they provide a lot of services and value that we don't. And sometimes people come to me from either big organizations or small, and they say, we're looking at using Let's Encrypt, here's what we want. We've just got to say, like, it sounds like Let's Encrypt is maybe not the right choice for you, but there are a bunch of options out there that make sense. So I think Let's Encrypt does make a lot of sense for a lot of people, but there are also a bunch of people out there who need the services provided by commercial CAs, and we're glad that they have those options. We don't see ourselves as competing with them.
Talking about other CAs, are there any efforts from Let's Encrypt or from the community to get other certificate authorities to adopt the sorry, I can't talk anymore. To adopt the ACME protocol?
Yeah, so when we made ACME originally, it was just something that we essentially made up for ourselves. So we designed it to work just for Let's Encrypt, and we didn't have a lot of other CAs as part of the conversation. But once we were up and running and we had the time and ability to do something better, we decided to go and standardize a new version of the protocol in the IETF called ACME v2. And the real reason that we did ACME v2 doesn't have so much to do with problems with ACME v1, but one of our principles is that we want the standard to be an actual standard that's built for everybody. And in the IETF, we were able to get a lot of feedback from other CAs and community members about what they would want in the protocol. So now we have ACME v2, and its whole reason for existence, basically, from my point of view, is to make the API work for more people than just Let's Encrypt. So I think the technical capability is out there, and now it's just up to CAs to choose to implement it. Obviously, we don't decide what they do. So I think there are a couple CAs out there that do implement ACME, and I have knowledge of more that are going to do it. I'm not going to put names out there, but I think it is slowly but surely gaining ground. I think you got to remember that, Let's Encrypt is a very new CA, so it's easy for us to do things like ACME because we're building everything from the ground up, and we have no legacy technology. We have no clients on old software stacks and things like that. But most of the big CAs out there, they've been around for a long time, 10, 20 years, something like that. I think a lot of them started in the 90s. And it's not easy to make huge changes like this. So, if you perceive that ACME is not being adopted as quickly as you would like, I don't think it necessarily reflects that CAs don't want to adopt ACME. It just takes time. Their CAs are built in a very different way than Let's Encrypt, and if they want to adopt ACME, it can involve some fairly complex changes to their operations.
The next question is kind of paraphrasing Richard here. So you talked before about Let's Encrypt being the CA and you wanting to be supporting many clients. Do you have any numbers for us, like which clients are quite popular, which are the most used, and quite specifically for our audience, where is Certmanager in this play?
I believe we do have that data somewhere. I don't have it around me, but I know that Certmanager is one of the more popular ones. So popularity when it comes to Let's Encrypt API usage has a lot to do with big organizations. So you can imagine that, for a long time, Google Clouds used Let's Encrypt. I'm not sure that they do anymore, but for a long time they did. Akamai uses Let's Encrypt. WordPress.com. So places like WordPress.com that host a massive number of sites, they end up being pretty dominant in statistics. So the question is not like how many actual people use a certain client. The question is what clients are being used at these organizations that host millions and millions of websites. So for some of those bigger providers, they've written their own clients, and so that it's just essentially a custom client for a certain large provider. a lot are adopting Certmanager now. Certbot from EFF is probably the most popular client among what I would call the long tail. So you've got, a lot of really large providers up here issuing millions and millions of certificates, but then you have collectively millions of small websites, with individual systems administrators and things like that. And Certbot is very popular, I believe, among that long tail. That's probably the best I can tell you today. You might be able to get more information if you want to ask that question on our community forums. Which, by the way, if anybody has any follow-up questions that we don't get to today, go ahead and ask on our community forums. There's a link right on the main page of the Let's Encrypt website. And me or our engineers, we're happy to try to answer your question.
Sounds like a great place to go. So we were talking like big clients like WordPress. I assume issuing certificates cost some money, at least in running the servers. What is the economic model behind Let's Encrypt? It's a non-profit, but how does it raise money to operate?
Yeah, so we are a nonprofit, and the majority of the money that comes in comes from corporate sponsorships. So we have a corporate sponsorship program with 3 tiers. There's platinum, gold, and silver. And there are a few platinum sponsors that contribute quite a bit of money per year, and we're really thankful for that. And then there's a larger number of silver sponsors that contribute between $10,000 and $50,000 per year. So most of our money comes from this corporate sponsorship program. We also receive some money from grants, which is probably our second biggest source of funding. Our biggest grant there, for example, comes from the Ford Foundation. And then we get individual donations, so that's people going to our website and donating $10 or $100 or something like that. And that is a small but growing portion of our income. So again, most of our money comes from corporate sponsorship, and that's been really stable for us. We don't require anybody to be a sponsor to access any of our services. Anyone can use our service. They don't have to pay. They don't have to be a sponsor. But I think there's enough people out there that recognize the value that we provide, that they're willing to advocate for their companies to step up and fund. Like I said, so far that's been very stable for us, and I expect that to continue. On the expenses side of things, servers and infrastructure are expensive, but by far staff are more expensive. So about 2/3 of the money that we spend goes towards staffing costs, and about 1/3 goes towards servers and infrastructure and other services that we use. And you can learn a lot more about this stuff by looking at our annual report. So if you go to let'sencrypt.org, I believe there's a link to our annual report right on the front page. And that gives you a better breakdown of how money comes in and how we spend money.
Sounds like great transparency.
But I guess one more thing I'll say about that is, these days we spend about $4 million per year. So we spend $4 million per year to serve, I think, almost 40% of websites on the web. We're, like I said, serving 225 million websites or more. So $4 million a year to do that is pretty low. So we're a very efficient organization in that respect. I think there are Fortune 500 companies that have internal PKI that cost them more than $4 million per year. So for us to encrypt huge parts of the web for $4 million a year, I think is a great value proposition. And we're really proud of that.
I got a totally unrelated question for you now. This is from the chat. Azure Key Vault has now the option to issue certificates from your colleagues DigiCert using the ACME protocol. Is there an option in the making to add Let's Encrypt as an issuer there? Not sure if you know the answer.
I don't know the answer, and if I did know, I probably would not be able to say. That's really up to Microsoft what they want to do there. But it's great that they are offering those services. I don't really care where people get their certificates. If you want to get them from Let's Encrypt, that's great, and we're happy to help you. If you want to get them somewhere else, that's awesome too. The important thing to me is that if you start a website get a certificate from somebody and make sure you're using HTTPS.
Use HTTPS, people. Okay, I got a fun one. So you now have your own root CA. What is the dance that you have to do with security around that key? And is there a Let's Encrypt bunker where the only physical copy of this key is stored?
There is something akin to a bunker, I would say, but to give you more of the story. So I think I mentioned before that these private keys are stored on HSMs, which are basically just small computers that are have a bunch of extra security measures on them. For example, they will, I don't know what you want to call it, they have tamper security systems. If you try to physically open them or something like that, it locks the system down. So they're basically just special computers to store keys. And they come in two forms. One is, I guess, what we would refer to as an offline HSM. It's relatively small, like let's say maybe the size of a shoebox or half of a shoebox. And so our root keys are stored in these offline CAs, or offline HSMs. And then those HSMs are stored in tamper bags, and they're inside a safe, inside of many layers of security inside a building somewhere. So the root keys are stored on these HSMs. And one of the important things about HSMs is that they won't export the key to us. So we don't actually know what our root key is, and we have no way of knowing because the HSM is built such that it won't actually tell us what the key is. We just do signing operations on the HSM. So you can imagine there's this little computer somewhere in a tamper bag, inside of a heavy-duty safe, inside of a secure room, inside of another secure room, inside of another secure room, inside of a building that is like earthquake-proof, has 5 different power supplies and all this kind of stuff. So that's the basic gist of how we physically protect the root keys. They're offline in a safe, so you can't really hack them because they're not even plugged into power, let alone a network. And they are never plugged into a network. The other type of CA is of what we call intermediate, or the other type of HSM we call an intermediate HSM. And that's what we actually issue certificates from every day, because obviously we're not going to issue from the root because that's offline. But the intermediates are essentially just rack-mounted, network-attached HSMs, and they have our intermediate keys on them, and that's what we sign with. And they can do, thousands of signing operations per second. They can do high volume, whereas the root HSMs, they do like 5 signatures per second because they're not really made for volume issuance. So those intermediate HSMs are in a rack in a secure room in a building. And then we have very secure off-site storage for backups of this stuff, both secure from people and secure from environmental issues. I think that's about as many details as I can give you.
Yeah, the HSMs are very interesting for the people in the chat room. I have 2 follow-up questions on those. If you can or may not answer, just please say so. Is there a backup HSM in case the one in the safe goes bust?
Yes. There are at least 3 copies in at least 2 different locations. I don't think I can be more specific than that, but yes, there are at least 3 copies, and they are in multiple locations in case one location were to have a major problem.
One more HSM question. Is this an off-the-shelf thing you use? Is it custom built? Can I go buy one in the store tomorrow?
So HSM as a broad term can be applied to a lot of things. Like, in a way, if you've heard of a YubiKey, it's kind of an HSM. It's the same deal, where it's sort of a special computer that you have cryptographic keys on, and you can sign or authenticate with them, but you can't actually get them off it. So obviously we're not talking about something along the lines of a YubiKey. We're talking about commercial HSMs. We do use off-the-shelf HSMs. It's not something custom that we built. There are only 2 or 3 major providers of these things, and they are pretty expensive. So I don't think you could walk into a store and buy one of these things. I don't think I've ever seen one in a store. But you could just call up an enterprise sales reseller and ask for one of these, and then they would put together a quote and ship it out to you. They are not cheap. Just giving you a ballpark without specific things, I would say, the smaller offline ones are probably in the ballpark of $10,000, and the network attached ones can be $30,000 to $50,000 per HSM, and then you've got support contracts on top of that. So they are not cheap, and they are not easily available in the store, but they are off the shelf, and you can buy them and order them. Yeah.
Yeah, I wish I made enough money to buy one, but I'll just keep using my YubiKey.
Yeah, I don't know if you actually want that. It would probably seem fun to begin with, and then you realize how much work it is to manage these things.
I'll just use shorter certificates with Certmanager.
Yeah.
I have a question from YouTube here. Can you see ACME being used more widely? There has been some proposals to use ACME or something ACME-like for workload attestation for services internally in a Kubernetes or Istio cluster. Can you see ACME being used there?
I don't think I'm qualified to answer that question. I'm sure that it can be used for internal PKI services. How exactly it fits into the software you're asking about, or that kind of environment, I'm not really sure. I'm sorry.
No worries. Back to a bit more Let's Encrypt then. What is the expiry time on the intermediate certificates? Are you keeping those low also, or do you keep a longer lifetime on those?
So the longest lifetime is for the roots, and those are, I forget the exact number, but somewhere between 20 and 30 years. And the reason we feel comfortable doing that is that those are very heavily guarded keys. They are not even plugged into power. They're not online. You can't hack them. You have to physically do a lot of damage to get to those. So we're comfortable with a long lifetime there. Intermediates are online in our data center racks, and they're issuing millions of certs per day. So they're a little more exposed, right? Because they're actually plugged in. They're on infrastructure. We work really hard to protect them, but they're not as well protected as the root keys. So those have a lifetime of about 5 years. So every 5 years we replace those. And then the end entity certs, because we really have no control over those, and people are doing whatever they're doing with them, those have the shortest lifetime at 90 days right now.
Continuing on certificate lifetime, so currently cross-signing with Interest, that one is gonna expire soon. You probably can still use it for the next month still with Let's Encrypt, but do you see any implications in the world of that root CA expiring? Are things gonna break?
I don't know what else is going to break. I don't know who else is using the IdenTrust root that's going to expire. You will be able to use that with us through September of next year. So it's more than next month. Next month, we are going to switch to using our own root by default, but you will have the option to continue using the Let's Encrypt cross-sign until September of next year. I think, like I said before, the biggest thing you want to think about when you're moving to our root is how much do you depend on traffic from very old versions of Android. So if a lot of your users are using old versions of Android, then you're going to want to probably stick with the IdenTrust root as long as you can. But if that's not really a problem for you, then you don't need to worry about it, and you can just switch directly to our root.
Thank you. So I've got a question from the chat again. Are you guys aware of any malicious root CAs signing certificates for normally Let's Encrypt protected domains, for example, by a state-controlled certificate authority?
I'm not aware of anything like that, no.
I think that's maybe interesting to ask some people who are monitoring the web. If you still have some questions, we still have 12 minutes of Q&A time left, so place your questions in the chat. I'll do my best to ask them. I still have one via Slack. What's the future for Let's Encrypt? Where do you see yourself going in the next 5 years?
Sure. So what we've been really busy with for the past 6 months is upgrading our infrastructure. So, database capacity, HSMs, storage, networking, just generally getting ready for the next few years. So the past 6 months have been a lot of infrastructure upgrades for us. As far as features go, we are hoping to add support for IP addresses within the next 6 to 9 months. So right now you can get certificates for domains, obviously, but in a little while you'll be able to get certificates for IP addresses so that you can speak HTTPS directly with an IP address. Most people probably don't need that, but for some people it's just easier to use raw IP addresses instead of domains, and we're excited to be able to offer HTTPS support to them too. One of the other things that I want to bring up, because I think it's an interesting topic, even outside the topic of Let's Encrypt, is we're always working very hard to secure Let's Encrypt, and every year we do more and more to make it secure. And one of the big efforts we're focusing on right now is removing memory safe, or code that is not memory safe, from our infrastructure. So we're sort of looking at where are we using C and C++ in particular. So there's the Linux kernel, there's stuff like nginx, Apache, parts of systemd. Where are we using code that is not memory safe? Because that code is relatively likely to have security vulnerabilities. So we want to get to a point where we don't really have to run very much code that's not memory safe. So we've been thinking a lot about identifying code that's written in C++ or C and getting it out of our infrastructure. And then starting to think a little bit about what is it, that's probably, if it's a good idea for us, it's probably a good idea for everybody else. So it's been interesting to look at what our options are, and yeah, we're looking forward to eliminating C and C++ from our infrastructure. But there's a lot of really critical software in the world that is still written in C and C++, even though we have a lot of evidence to back up the idea that it's just not safe. We live in a world where when somebody says, let's spin up a reverse proxy, a good engineer will say, yeah, I'll go and I'll spin up nginx and we'll take care of it. But what you're doing when you do something like that, whether it's nginx or anything else, I don't mean to pick on nginx too much, you're spinning up, 3 million lines of C code on the edge of your network to handle untrusted input. We just have mountains of evidence to know that that is not safe. So I'm looking forward to getting to a point where people recognize that that's not safe, and we develop other options that people become comfortable with, so that, maybe 10 years from now, the idea of spinning up 3 million lines of C code on the edge of your network to handle network data, people would think, oh, that's a crazy thing to do. Whereas today, that's a pretty normal thing to do, but it should be a crazy thing to do. We know that it's not safe and we should stop doing it. So we're thinking a lot about that internally at Let's Encrypt, trying to get that code out of our infrastructure. And we hope others are thinking about it too.
That's great. I got 2 follow-up questions on this one. What will you be replacing it? I got a Rust fan in the room. Will it be Rust? Will it be Go? Will it be Python? Or does it depend?
I think it depends on what's being done. There are a bunch of great memory safe options. Most of the Let's Encrypt CA is written in Go. We are big fans of Rust, although we have not used it for very much yet. I don't think we're going to go out and write our own replacement for nginx, right? We're going to look at options that other people have written. So I don't know what we'll end up choosing. And for some things, we've already replaced them with Caddy, which is a server written in Go. For other things, we're going to need something else. So I don't know what we're going to end up doing. I think, Go, Rust, they're all great options. We'll see where it goes.
You immediately answered the second question, what to replace nginx with. Thank you. Back to Sorry.
Go ahead.
Okay. back to the IP issuance, are you gonna block some IP ranges from there? Are you just gonna accept any IP? Are you gonna allow like everything that ends with all of the Amazon shared IPs or something? What are the security protections there?
So this is where I'm going to have to tell you up front again that I am not one of the engineers working on this project. So take my answer here, as a rough answer. I don't believe that we're planning to block any normal public IP address ranges. We will be blocking some that are reserved for certain uses that are not the public internet, like, well-known local IPs or something like that. But I don't believe that we're planning to block any normal public IP addresses. I hope that answers the question well enough, because I don't think that I can answer it better than that right now. Again, if you want to know the details of this and talk to our engineers, the Let's Encrypt community forums are a great place to ask a question.
Thank you. I have another question back to nginx, but I think that might be also better for the community forums. I'm going to try anyway. So if you say this is too engineering, send it to the community, please feel free. How does Caddy, and then an ampersand here, how does Caddies and not being battle tested against nginx weigh up against nginx being written in C?
Can you repeat the question a little slower?
No worries. How does Caddies and being up, it's also somewhere for us, sorry. Being not as battle tested as nginx, you'd weigh up. Thank you, Frederick, to admitting you've written it poorly. Let me try again. How does Caddies and not being not as battle tested as nginx weigh up against nginx being well battle tested but written in C?
Yeah. So I think the question here is, Caddy is memory safe, but it's newer and maybe has more bugs or something, whereas nginx is very well tested, but it's written in C. That's a great question. So we still use both. We have not replaced nginx with Caddy. We've replaced some things with Caddy, but not everything. And part of that has to do with what you're getting at here, where, we are very confident in nginx for certain things, and we're happy with Caddy for other things. So we have not replaced everything with Caddy. We still use nginx for some things, and we're still looking for what we want to replace nginx with ultimately. I think if we're talking long-term here, though, yes, nginx is very well tested, and that's a great quality to have. But we're going to be using stuff like nginx for the next 50 or 100 years. This is not going to go away. And eventually somebody's going to have to rewrite something that ends up replacing nginx. And maybe that's Caddy and maybe it's something else. But we need to get started now so that we can start this process of quote unquote battle testing the software, so that 10 years from now we have an alternative to Apache or nginx that is memory safe and battle tested. So I can certainly understand why people want to use nginx because it's so well tested, even if it is written in C. But I think we also need to start putting in the effort so that we're not in the situation where we have to make a choice between battle tested and memory safe. We need both, and so we need to get started on that now. Yeah, I hope that answers the question.
Certainly does to me. I'm going to send you the last question because we have 3 minutes left and I still want to say thank you in the end. Are certain parts of your code base formally verified, e.g. COC, ACTA, or verified C?
Well, we don't write C code as a matter of policy. We don't allow anyone to run, our engineers don't write C code. I don't believe that any of our code has been formally verified. It does get audited sometimes, but what has been formally verified is the ACME protocol itself. So we funded some research done by INRIA in France, where they formally verified that the protocol was secure, and that went really well.
Thank you. So I think we're going to end this here. So thank you very much for your questions. I even learned a lot. I know a lot about Let's Encrypt, and yet I still learn today. So you were very, very helpful here.